Since 2012, researchers at the University of Illinois have been studying the use of grass growing on highway rights-of-way as a renewable energy source that could pay the cost of highway mowing. It could also provide fuel for Illinois Department of Transportation vehicles and improve the sustainability of electricity generation. IDOT, the Illinois Department of Transportation, maintains more than 100,000 acres of non-paved public land along highway rights-of-way. Mowing directly adjacent to the roadway is necessary for traffic visibility and safety, but the remaining right-of-way could represent a wasted opportunity, non-productive land that might be put to work for the people of Illinois. IDOT asked the University of Illinois to investigate the feasibility of planting fast-growing perennial grasses as an energy crop. For the multidisciplinary team, the 3-year project was not an academic exercise. These engineers, chemists, and biologists were determined to cover all the angles from the energy potential of the plants to the practical forces that support a biofuel market.
This project is looking at the feasibility of planting energy grasses along Illinois highway right-of-ways from the standpoint of economics and also from the standpoint of whether this is a sustainable process. As we modeled our results, we project that we can have several millions of dollars of savings that the Illinois Department of Transportation could in fact benefit from. So I think that's very exciting. We're not just talking about a study that suggested something and then that data was never actually put into play. This actually has some real-world potential for saving the Department of Transportation some significant dollars.
If you want to look behind me and see what's out here, you'll see a lot of variation. For instance, this one in front of me is switchgrass, and the one I'm standing in is also switchgrass, but then this leafier one is big blue stem, and even though it's short now, as it starts to mature and then go into the reproductive stage, it actually will be the tallest one out in the field. Additionally, you see this prairie cordgrass here. It's very sparse within the plot, but it does have a rhizome structure that will fill in this area, and this one will put out reproductive tillers that will then be well over my head. And then the Indian grass over to this far side is, even though it's one of the shorter ones, it does acts a lot like big blue stem, and as that matures and elongates too, it will have very tall stems as well.
Knowing the composition of the feedstock coming in for a large facility would be very important. A lot of times they have certain specs, like they would need a sugar content between X and Y, and a moisture content between X and Y, and maybe an ethanol extractive content between X and Y. They know their processes and their systems, so they have certain tolerances of what they can accept as a feedstock in a biomass refinery.
It's a really interesting challenge because, you know, with all the interest in the research in biomass energy systems, they're still not a big player. And so the upfront capital costs and the supply chain costs are a really critical factor. Since there's not a widespread use of biomass for energy, then we have a limited supply chain. We can use this opportunity to help raise the supply chain and help foster it along. One way, a little bit more concretely, that we're thinking about doing that is just doing a very small supply chain using biomass for an IDOT maintenance facility. As a scale-up opportunity, we're also starting to talk with commercial companies that are interested in making pellets out of it. And there's also other companies converting some of the biomass into fuels. So we're working in small ways within the department itself, and then trying to imagine larger ways by working with existing commercial actors in the supply chain.
This material is competitive with a lot of your petroleum products. particularly in rural areas, areas of Illinois that are not served by natural gas, where propane is the primary fuel used for heating. We're actually displacing a cost that we can displace. That doesn't come around very often. This is kind of combining what nature can provide as a renewable versus what nature provides as renewable only in geologic time when we're talking about the petroleum-based fuels.
We conclude that if we use 50-50 grass pellets and wood pellets, the emissions are very similar to wood pellets, and then the efficiencies are also similar to wood pellets, and we are not seeing any operational problems. The state of Illinois requires that we reduce the amount of coal and we increase the amount of renewable fuel in our power plants. This is an effort to meet that criteria by using it in the power plant.
This image here shows us utilizing the near-infrared wave bands where grasses are, where pavement is, where standing water might be. And you can see these on this particular image in the gray areas. Where are the most likely places where we can grow the biomass? And in those blue, the deeper blue bands, those are the parcels that we've identified where we could grow biomass at a reasonable scale. We're in the process of doing that all the way throughout the state, all 102 counties in Illinois. If you actually harvested all the biomass in all those parcels throughout the county, if you were just going to handle heating and power at the depot in DeWitt County, you actually have more biomass than you really, really need. So we started thinking about what's the real demand you want to satisfy, and at that point, which of the parcels would you select to meet those specific demands. Our first parcel is a 20% scenario, and what ends up happening is that you get biomass from some of the bigger sites so long as they're closer to the depot. As you start to add more demand, going up to 40%, you start to bypass some of the sites you previously harvested to go grab some others because they turn out to be bigger. And then you might come back and go through until you keep scaling it up to 60 and 80 and 100%, where finally you've scheduled the operations for really the entire county. So all these things actually boil down to cost for the most part. Our analyses, this one's showing about $22 for a megagram or a metric ton of this material. And that's a pretty attractive price. You know, what is driving this price? Well, you can see on this particular pie chart, we've distributed the cost across the whole supply chain, whether through the whole harvesting operation, as well as the supply chain, the transportation operation.
The Integrated Bioprocessing Research Laboratory is a facility that has been designed specifically to address the gap between work that has been done at the bench here at the university and commercialization. It will provide a pilot space facility together with an analytical laboratory that allows us to carry out proof of concept activities with potential products and processes that seem to have potential viability.
As part of the university and all land grants across the country, and their role is to help transfer technology and help show the value of the research that's accomplished by the University of Illinois. We're at a time period fiscally and governmentally where resources are very tight and very hard to stretch. As I relate to the taxpayers, I want to be able to go to them and say, this is a valuable project that could be put in place now.